So, welcome back. Today, I would like to discuss the most important questions of Module 5. So, let's start with the first question. What is a Spark? Explain its features and use cases. This is the most important questions and asked in most of the question paper. So, Upbeat Spark is an open source cluster computing framework. Its primary purpose is to handle the real-time generated data. Spark is an open source clustering computing framework. Its primary purpose is to handle the real-time generated data. It supports HDFS, that is Hadoop distributed file systems compatible data. Spark has a simple and expressive programming model. Expressive programming model implements a number of mathematical and logical operations with a small and easier written codes, which a compiler as well as a programmer can understand easily. Spark processes the data much quicker than the other alternatives. Applications of an expressive code are in analytics, extract, transform, load, and machine learning, stream processing, and graph computations. So this is the basic definitions of it. So let's recall what we have learned. Apache Spark is an open source cluster computing framework. Its primary purpose is to handle the real-time generated data. It supports HDFS compatible data. Spark has a simple and expressive programming model. Expressive programming model implements a number of mathematical and logical operations with the smaller and easier written code, which a compiler as well as a programmer can understand easily. Spark processes the data much quicker than other alternatives. Applications of it is used in analytics, code analytics, and extract the transformed load, machine learning, stream processing, and graph computations. So these are the definitions of Apache Spark. Next, coming to the features of Apache Spark, the features of Apache Spark is uh, Spark provisions for creating an application that uses the complex data. In memory, Apache Spark computing engine enables up to 100 times performance with respect to the Hadoop. So execution engine uses both in memories and on disk computing. Intermediate results save in memory and spill over to the disk. Next, the data uploaded from the open object store for immediate use as a Spark object instance. Spark service in interface sets up the object storage. Provides a high performance when applications access a memory cache further from the disk. So next is an API to define and resilient distributed datasets. ROD is a programming abstract. ROD is a core concept in Spark framework. ROD represent a collections of an object stores distributed across a many compute nodes for the parallel processing. Next is processes any kinds of data, namely the structured, semi-structured, unstructured data arriving from the various sources. Supports the many new functions in addition to the map and reduce functions, and optimizes data processing performance by slowing the evaluations of the big data queries. Provides in conscious and consistent APIs in the Scala, Java, Python. Spark code are in the Scala and runs on the JVM environment. Supports Scala, Java, Python, and the R language. Use case of a Spark. In a big data analytics, it is used in the real-time data processing and machine learning. ETL, that is extract, transform, and load, widely used for the data cleaning processes, and graph processing, log and event analysis. So these are the major use cases of Apache Spark. Next question, with the need diagram, explain the main features of Spark. So the main features of Spark I have explained here itself, but if they ask only for the features of Spark, with the need diagram we have to explain it. In memory, Apache Spark computing engine combines SQL, streaming, graphics, and ML libraries. Conscious and consistent high-level APIs in Scala, Java, Python, and R, and optimized engines that supports a general executions graph, general purpose cluster computing system, API for the resilient distribution, distributed data sets. So this is the the features and the diagram of the features of Spark. Moving on to the next questions. With the need diagram, explain the 5-layer Spark architectures and its working. So this is a 5-layer. First one is application layer. Next is application support layer, processing engine, data storage, parallel task, and resource management layer. So these are the major 5 layers. The main components of Spark stacks are SQL, streaming, R, graphics, ML, it is ML libraries, and Arrow at an application support layer. Spark Core is the processing engine. Data storage provides the data to the processing engine. Hadoop, Yarn, and Mesos um, facilitates the parallel running of the task and the management and scheduling of the resources. Application layer, this is the topmost layer, and user will write the applications using a scale, Java, Python, or R. Applications can be a batch processing, a streaming, ML, or the graph based. These applications interact with the Spark through the high level API. Next is API layer, that is provides an high level libraries to simplify the development. Spark SQL, Spark streaming, MLlib, and graphics. Next comes Spark Core, that is processing layer, the heart of the Spark architectures. And these are the components or the thing that is performed there. Next is cluster manager layer, responsible for the resource management, allocates the CPU, memory, and other resources to Spark applications. Next is a storage layer, stores input and output data. Spark can read the data from the various storage like HDFS, cloud object storage, NoSQL database, and local file systems. So these are the major applications of it. 5 layers of it, working of 5 layer. And coming to the next questions, compare the Spark and Hadoop in terms of data pre-processing speed and the real-time analytics. So we have to, there is a sum of the differences. So based on the speed and the real-time analytics. So first one is Apache Spark and Apache Hadoop. Very fast due to in-memory processing. Data is caged in the RAM, reducing a disk IO. Slower because data is read and written to the disk at every map and reduce stage. Use in-memory computations with optical disk spill when needed. Uses disk-based batch processing models. Intermediate results are stored in the memory, improving the processing speed. Intermediate results are also written to HDFS, increasing the latency. Well suited for the real-time and the near real-time analytics using the Spark streaming. Not suitable for the real-time analytics, designed mainly for the batch processing. Low latency makes it ideal for the interactive queries and the streaming data. High latency not suitable for the real-time analytics. Native support through the Spark streaming. No native real streaming support. So these are the major differences, in comparison between the Sparks and Hadoop. So I hope this is clear. Coming to the next questions, explain the Spark SQLs and the pandas for performing the data analytics. So yeah, this is also a very important question. Spark SQL is a model of an Apache Spark used to process the structured and semi-structured data. It allows user to query data using SQL like syntaxes and also work with the data frame and data sets. So data is loaded from the source like HDFS, JSON, and CSV or any other file format. Data is represented as data frame which are distributed across the cluster. Users can analyze the data using the SQL queries or data frame API. Spark SQL uses the Catalyst optimizer to optimize the queries and improve the performance. Executions is handled by the Spark engine using an in-memory processing. Features of a Spark SQL supports SQL queries and large data set distributions across a multiple nodes. Optimize query executions using a Catalyst optimizer. Integrates with the Hive and supports a Hive QL. Next, suitable for the batch and the real-time analytics. Use case big data analytics on a massive data set. ETL operations, data warehouse and reporting. Interactive data analysis at the scale. Coming to the pandas is a Python library used for the data manipulations and analysis. It is mainly designed to work with a small to a medium-sized dataset on a single machine. Pandas perform the data analysis based on this. Data is loaded into a data frame from the CSV, Excel, or SQL database and provides rich functions for the data cleaning, filtering, grouping, and aggregations. Data is processed in memories on a single system, offers a easy integrations with the NumPy and Matplotlib for analysis and visualizations. Features of pandas: it is very simple and easy to use. Python syntax, a powerful data frame structures, ideal for the data cleaning and exploratory data analysis. Fast for the small data sets. Excellent support for the data visualizations. So this is the use case of pandas: data cleaning, statistical analysis, and data visualization, exploratory data analysis. So these are the use case of pandas. Next is text mining. This is also one of the important questions which is repeated in the model question papers. Text mining refers to the process of deriving a high quality information from the text. You are extracting a very high quality from the text. Another definition is text mining is a process of discovering and extracting the knowledge from the unstructured data. So I recommend these two out of these four definitions. Any of this two will be a better. So coming to the next definition, text mining is the process of analyzing collections of textual context in order to capture the key concepts, themes, uncover hidden relationship, and discover the trends without requiring that you know the precise word or terms or that authors have used in express those concepts. Text mining is a technique which helps in revealing the pattern and relationship in large volume of textual context that are not visible to the naked eyes, leading to a new business opportunities and improves the in a processing. Applications: mail filtering, drug action report, fraud detections, and knowledge management, and social media data analysis. These 4 to 5 are the simple applications. If they ask for the core application, this is the core applications. And natural language processing is a technique for analyzing the understanding and deriving the meaning from the human language. For that it is used. Information retrieval, for information extraction, document clustering, document classification, and concept extractions. So first is natural language processing, information retrieval, information extraction, document clustering, document classifications, and concept extractions. These are the major applications of it. So coming to the phases followed, this is how the text extractions exactly takes place. This is a text and this is tokenization. Here is a text, and these are the different 5 phases where the things will take place. In the first phase, text pre-processing enables this synthetic semantic text analysis and does the following. First is text cleanup, process of removing unnecessary and unwanted informations. Text cleanup converts the raw data by filling up the missing values, identifies and removes an outlier, and resolves the inconsistency. Next is tokenization. It is a process of splitting the clean up text into a tokens. That is, if there is a set of sentences, splitting up into words and using a white space or punctuation marks as a delimiter to separate those words. We use a white space or the punctuation marks as a delimiter. Part of speech POS tagging is a method that attempts labeling of each tokens with an appropriate POS. Next is words sense disambiguations is a method which identifies the sense of a word used in a sentences that gives a meaning in case of word have a multiple meaning. If it's the same word is used, if in some cases a single word will have the 2 different meanings. So by analyzing the sentence only we can come to know that in which perspective they have used that word. Next, parsing is a method which generates a parse tree for each sentences. Next is phase 2. Feature generations is a process which first defines in a feature, and some of the ways of the feature is feature generations. The backward model represents a textual document by the word it contains and their frequencies. Next is stemming identifies. I'll just go through it. The main points, which is more than enough. Stemming identifies a word by reducing it to its root or the base words. Next is removing the stop words from the feature space. They are the common words, unlike to help the text mining. This is vector space model is an algorithm model for the representing the text document as a vector or an identifiers word frequencies or the terms is a document index. In the document index, in the phase 3, features selections is a process of selecting a subset of the features by rejecting an irrelevant or a redundant features according to the defined criteria. So dimensional reductions, that is feature selections, is one of the most method used in of division, and there are generally two, that is principal component analysis and linear discriminate analysis are the dimensional reduction methods. N-gram evaluations is the next method. Noise detections and evaluations of uh, the given data is the next step followed in it. Data mining techniques enables the insights about the structured data that results from the previous phases. So examples is unsupervised learning, supervised learning, and identifies the evaluatory patterns in the temporal text streaming. And the method is useful in the wide range of an applications. Just pause the video for 2 to 3 minutes and just go through it. You'll get a clear idea. It's a basic simple things. And in a phase 5, analyze the results, evaluate the outcomes of a complete process, interpret of the result, visualization, and using the result for the further improvement and actions of the enterprises, industries, or the institutions. So that's all. So this is not that important question, I guess. Yeah, that's all. So thank you for watching. Please go through the questions and answers once again. It will help you to get or to score the good marks. Thank you for watching.